In this video we look at Chebyshev's theorem and also the coefficient of variation. So these are topics related to standard deviation in Chapter 3 of your textbook. So Chebyshev's rule is a way to determine percentages of data that are within a certain number of standard deviations away from the mean. So if we think of K as the number of standard deviations away from the mean, Chebyshev's looks at how many standard deviations you are away from the mean and what percentage of data are within certain ranges. So the general formula is 1 minus 1 over k squared. So the result of this, if you think about it, if k is 2, if we look at the mean plus or minus 2 standard deviations, if you plug in k equals 2, you get 1 minus a fourth, or 3/4, which is 75%. So Chebyshev's theorem would say 75% of data fall within 2 standard deviations of the mean. If k is 3 or 4, you simply plug those in. So you can see as you get more and more standard deviations away from the mean, a bigger percentage of the data is within that range. So let's look at this in terms of an example. Suppose we look at the number of hours of television watched by a college student, number of hours per week. So we do a sample and find the average is 14 and the standard deviation is 3. So if we think in terms of standard deviations away, so if I go 2 standard deviations away from the mean is at 14, the standard deviation is 3. So if I go 2 standard deviations, that's 6 hours. So 6 hours below would be 8, 6 hours above would be 20. So within 2 standard deviations, I would know that at least 75% of college students watch between 8 and 20 hours of TV each week. Similarly, if I looked at 3 standard deviations, 3 standard deviations would be plus or minus 9. 3, 6, 9. 3 standard deviations away, so that would be from 5 to 23 hours of TV. And so 1 minus 1 over k here gives me 89%. So at least 89% of college students watch between 5 and 23 hours of TV each week. The nice thing about Chebyshev's theorem is it works for any data set. Skewed, symmetric, doesn't matter. There is no assumption. Later in the textbook, we'll look at an empirical rule, which is a similar rule for determining percentages within a certain number of standard deviations, but that one is specific to a normal distribution, a very symmetrical distribution. Next, we have the coefficient of variation, or CV, and this is a relative measure of variation. It is a measure of variation because it measures spread of data, but it's relative to the size of the data. So the formula is simply the standard deviation divided by the mean, and then you multiply it by 100%. So for example, suppose we had a survey that found the average individual cell phone bill was $71 and the standard deviation is 19. What would be the CV? Well, I'd take the standard deviation of 19 divided by the mean of 71 and multiply by 100%. So I get 26.8%. So the coefficient of variation is 26.8%. And it's a measure or a relative measure of variability. It gives me the amount of variability relative to the size of the data. And so that is coefficient of variation.